Today I am going to discuss one of the important topics about the partial discharge, that is the measurement of the partial discharge. Before going in the deep description about the measurement of the partial discharge, uh, already I have kept some of the videos regarding the partial discharge, so you can refer that part. And this part that I am going to discuss about the measurement of the partial discharge. So partial discharge can be measured using the various methods or the techniques. That the what is the normal definition of partial discharge is partial discharge is a localized breakdown of electrical insulation that occurs within an electrical system, such as cables, transformers, circuit breakers, or the switch gears. it, it is important to detect and measure partial discharge because it can be an indication of insulation degradation and potential equipment failure. There are few common methods used to measure the partial discharge are HFCT. HFCT, that is called the high frequency current transformer. Second one is the capacitive coupling. Third one, ultra high frequency. Fourth one, acoustic emission. Fifth one, that is the electrical impulse measurement and the internal sensors. So these all are the techniques or the methods to measure the partial discharge. So first, the HFCT. How can we measure that? I have shown the diagram of the HFCT here. HFCT diagram. And the HFCT is commonly used method for the measuring the partial discharge in electrical system. It operates based on the principle of detecting the high frequency current pulses produced by the PD, that is the partial discharge. The HFCT measurement techniques typically works: first one, installation; second one, signal conversion; third one, amplification and conditioning; fourth one, signal analysis; fifth one, data interpretation. And these all are the steps. First one, in the installation part, the HFCT is placed around the cable, conductor, or other electrical equipment being tested. It acts as a current sensor and captures the high frequency signals generated by the partial discharge. Signal conversion. The HFCT converts the high frequency signals into measurable currents. The signals induced in the HFCT winding are uh, proportional to the partial discharge current flowing in the tested equipment. Third one, amplification and conditioning. The current signals from the HFCT are amplified and conditioned to ensure optimal measurement accuracy. This may involves using the amplifiers, filters, and other signal processing techniques. Fourth one, that is signal analysis. The amplified and the conditioned signals are analyzed to determine the characteristic of the partial discharge. This analysis can induce identifying the magnitude, frequency, content, time domain, features, and other parameters of the partial discharge activity. That is, fifth one is the data interpretation. The measured data is then interpreted by experts familiar with partial discharge analysis. They can assess the severity of the partial discharge, identify uh, potential issues in the electrical system, and make recommendations for the maintenance or the corrective actions if necessary. The HFCT are widely used in the various applications, including the power cables, transformers, switchgears, and the rotating machinery. They are particularly useful for the online monitoring and the condition assessment of the electrical assets, as they allow the continuous measurement without the need of the shutdown. The second is the capacitive coupling. This method involves using the capacitive sensor. They are coupled with the insulation of the equipment under test. The sensors detect the electromagnetic waves generated by the partial discharge events and convert them into the electrical signals for the analysis. CC is mostly used for the online partial discharge monitoring systems with sensors are permanently installed in the equipment. Third one is the UHF, ultra high frequency detection. The UHF detection involves placing the UHF sensors or antennas near the equipment under the test. The partial discharge events generate the electromagnetic waves in the UHF range, and the sensors captures these waves for the analysis. UHF detection is particularly used for the detecting the partial discharge in the switchgear and the transformers. Next one, the AE, that is called the acoustic emission detection. Uh, this type of detection of the acoustic signals are generated by the partial discharge events. Specialized sensors or the microphones are used to pick up that signals, and their characteristics such as the amplitude and the frequency are analyzed to identify and measure the partial discharge. That is, fifth one is the electrical impulse measurement. That is, it measures the electrical impulses generated by the partial discharge events using a specialized voltage or the current sensors. These impulses are typically high frequency pulses that can be analyzed to determine the presence of the severity of the partial discharge. So these all are the methods that is used to measure the partial discharge. And the sixth one is the internal sensors are also used to measure the partial discharge. So